And in today's episode, among other things, you'll see that humanoid robots have already started leaving factories in industrial batches, while others are starting to work side by side with autonomous vehicles, thus forming complete teams within real production lines. We'll also talk about machines that are taking on roles in the streets, like traffic agents, for example. And I can't forget to mention systems that are, in quotes, gaining brains capable of coordinating the entire body, the whole thing. Robots that are breaking the physical limits of speed. And Elon Musk is reconfiguring his factories to produce humanoid robots on a scale never seen before. And in the midst of all this, a new generation of artificial intelligences that not only talk, but can also act directly in our world. Let's try to understand all of this. Hello, impressed viewers. I'm Carlos Alves, and you're watching Amazing Reality. And all these advances and consequences that artificial intelligence is bringing up raise a point that we really need to face with maturity. Because when the head of Google himself says that no job is really safe, not even his, that's not just a distant prediction. It's a sign of the present. The market isn't ending, it's changing quietly. But yes, it is changing. There are fewer stable jobs, more fragmented tasks, and increasingly more demands for those who know how to use technology. And this is where I need to be honest with you. Those who don't learn to use artificial intelligence in the coming years won't just lose their jobs. They'll stop being considered fit for them. And I recommend Aria to you, Genesis's artificial intelligence, which you've seen me talk about here on the channel for quite some time now. And one of the reasons I really do this is because it's different from other platforms that only give you access to the models. Our Aria X actually gives you a strategic advantage. And that's thanks to the new AX Fusion. This is the smart engine behind the platform. You don't need to choose an artificial intelligence model, even though there are several available. You just need to start a conversation, and the system understands your intention. It uses the best model for what you want. Chat, generative pre-trained, transformer Diminy, Cloud, Grok, Perplexity. In other words, you just type and you'll get the best possible result. All of this is combined to deliver more accurate answers, smarter texts, deep analysis, and real productivity. The link is here in the description and also in the pinned comment. And you watching me big on your TV? I know a lot of people do that. Use the QR code that's on your screen. I think it's here. I'm never exactly sure if it's here or here, but it'll be somewhere. Just click it. Thanks, yeah. There's a specific moment when technology stops being just a promise and actually becomes a real presence. And it's not when a prototype appears, and it's not when a viral video shows up, but it's when dozens, hundreds, and thousands of units start coming off a production line together. And that's exactly what has just happened once again in China. The company Dobot announced the third batch of its full-size industrial humanoid robot, Atom, officially marking the beginning of the mass production and delivery phase of humanoid robots to real factories. Recently released images show rows of humanoid robots walking in sync, maintaining bipedal balance, performing coordinated movements, and carrying out assembly tasks. In Atom's configuration, it has degrees of freedom, hands with 5 articulated fingers, and a gait designed to resemble the human locomotion pattern. This allows it to walk, stop, turn, balance itself, and of course, manipulate objects with fine control. But perhaps the most important point isn't in these specifications, but rather in where these robots are being deployed. A newly unboxed Atom was deployed in a real industrial environment, outside of laboratories and tech fairs, with no custom programming and no extensive adjustments. It worked on its own, and according to the engineers in charge, it demonstrated repeatable movements, stable pressure, and consistent execution of previously defined tasks. This means that the industry has just entered a new phase. It's no longer about creating humanoid robots capable of doing acrobatics. It's about creating robots reliable enough to repeat a task thousands of times without failing. At the same time that all of this is emerging, the limitations remain clear. Atom still doesn't make spontaneous decisions, which are complex. He doesn't improvise, he doesn't learn on his own during a shift. He just performs what he was very well trained to do. And paradoxically, it's exactly what the industry wants right now, because factories don't need creativity. They need predictability. Perhaps the most symbolic thing is the reaction inside the factories themselves. Human workers report curiosity, as well as getting closer to and even talking to the robots. If these machines are already starting to be born on an industrial scale, the next step is not just to produce more machines, it's to make them work together, as if they were a single system. And in China, another startup, Robotics, has just validated exactly this scenario through its subsidiary, UQI. The company confirmed that the autonomous vehicle Cheeto Alpha successfully completed production validation tests inside Foxconn's new energy vehicle research and development center in Zhengzhou. In practice, this means something much bigger than just a simple test. Cheeto Alpha went through a closed, complete production cycle from testing to moving around inside the factory, even to final delivery, and all of this without humans. In the process, everything happened autonomously. This kind of validation is considered one of the last major obstacles before mass production, because it proves that the system can, in fact, work outside the lab on a real factory floor, with noise, people, obstacles, and constant route changes and variations. The Cheeto Alpha is classified as a Level 4 vehicle, which means it can operate on its own in defined environments, without continuous human interference. But what I really want to say is that the difference isn't just in the vehicle, it's in the ecosystem. Optech has been building a system where different types of robots work together, like a single gear in the BYD Industrial Park, for example. Cheeto Alpha operates side by side with robotic forklifts, heavy mobile robots, and even Walker S2 humanoids. Cheeto Alpha operates side by side with robotic forklifts, heavy mobile robots, and Walker S2 humanoids. While the vehicles transport the loads, the humanoids handle the parts, the forklifts organize the pallets, and the central system coordinates all of this. No breaks, no shifts, no business hours. The company calls this architecture an unmanned end-to-end logistics solution. In practice, it's a factory that starts operating like an organism. Sensors play the role of senses, control systems function like the brain, and the vehicles and robots become the muscles. The true brain of the system. It's an orchestration software that distributes tasks, adjusts routes, and avoids conflicts in real time. If a corridor is blocked, another robot takes over. If a humanoid is busy, a vehicle redirects the load. Nothing stands still, waiting for human orders. This model radically changes the concept of industrial efficiency. Today, a large part of the time lost in factories isn't in production itself, but in the movement of materials, fetching parts, transporting components, taking items from one sector to another. In other words, by automating this, the factory starts operating in a continuous flow. And when factories start operating with almost 100 people nearby, it becomes inevitable to ask, how long until this model leaves the warehouses and reaches our streets? Let's answer that now, at the beginning of this year, here in 2026. The company AI Maga Robotics has officially started deploying the humanoid robot Z-Ring R001 as an urban traffic control agent in cities like Wuhu and Hangzhou. The robot wears a uniform, displays a badge, and occupies exactly the same physical space that was previously reserved for human police officers. Its main function is simple, and that's exactly why it's powerful: to perform standardized hand gestures for stop, go, attention, and wait with a fluidity similar to that of a human, thus keeping the flow organized. But behind these movements, there's a much deeper system. The humanoid is directly connected to the city's digital infrastructure. It communicates with traffic lights, monitors vehicles, tracks pedestrians, and analyzes risk patterns. For example, if it spots a cyclist without a helmet, it gives a polite, audible warning. If a car goes beyond the line, it gives an immediate alert if a pedestrian crosses outside the crosswalk. It guides. It doesn't fine, it doesn't chase, and it doesn't confront. For now, it only prevents, and that completely changes the logic of urban policing. The goal, according to the company, is not to replace human police officers. Paradoxically, it's to take them out of this sector. Intersections are among the most hostile environments in a city. Constant exposure to toxic gases, high noise levels, standing for several hours, repetitive movements that cause injuries, and the real risk of being run over. While the Z-Ring R001 handles the predictable routine, human police officers can focus on accidents, conflicts, investigations, and situations that require judgment, as well as empathy and complex decision-making. And if you, like me, are wondering why use a humanoid robot if just cameras and smart traffic lights could do the job, the answer lies in psychology. We as human beings respond differently to physical presence. When a humanoid-shaped body raises its arm in a stopping gesture, the brain automatically interprets that as a direct social command. This is faster, more intuitive, and harder to ignore. In addition, there is the so-called observation effect. We definitely don't behave the same way in front of a post as we do in front of something that seems to be looking at us. The humanoid does create a presence, but for a robot, it's about doing a bit more than just organizing traffic. understanding the context, and making decisions. It needs something far beyond motors and sensors. It needs a brain. And in China, the company Linux Dynamics has just raised about $200 million in a Series B round, precisely to accelerate this frontier. To create robots with embedded intelligence, that is, machines in which the body and the brain are conceived as a single ecosystem. Instead of an isolated AI running on distant servers, the robot itself starts to learn from movement, balance, contact with objects, and interaction with the environment. This is what experts call physical AI. This goes beyond traditional artificial intelligence. At the center of this strategy is a platform called COSA, described by Linux as the nervous system of its humanoid robots. COSA works as a cognitive operating system capable of controlling the entire body of the robot in real time. Arms, legs, torso, balance, and object manipulation. The company compares this architecture to the human brain, more precisely to the region of the brain responsible for coordinating fine and fluid movements. In practice, this means that the robot doesn't just execute pre-programmed sequences. It understands the context of what it's doing, and at this level of autonomy. The result is the integration between COSA and the company's second major technology, the Tron 2 platform, which is a modular system of limbs, joints, and torso that allows different types of robots to be assembled from the same base. The company's main humanoid, called Ollie, is 1.65 meters tall, weighs about 55 kilograms, and has arms with 7 degrees of freedom each, capable of carrying loads of up to 10 kilograms. It can already overcome obstacles, walk on moderately rough and uneven terrain, recognize small objects, and grasp them with great precision. In a recently released video, 18 Ollie robots are shown coming out of transport containers on their own, standing up, marching in formation, and performing synchronized movements. It's a clear account of where robotics is heading, no longer for machines specialized in a single task, but for general platforms capable of learning new behaviors over time. For Linux, this funding isn't just about building better robots. It's about accelerating the creation of a new kind of intelligence. An intelligence that is born from the body, that learns by walking, making mistakes, balancing, and touching. If this path keeps advancing at the current pace, the future of robotics won't be defined by machines that just obey, but by machines that understand the world through their own experience. And when this brain starts to exist, the body also needs to keep up, right? And that's when the physical limits start to fall. A Chinese company called Mirror Me Technology has introduced what it claims to be the fastest humanoid robot in the world. Its name is Bolt, and I also thought of Usain Bolt. And during real-world testing, it reached a speed of 10 meters per second. And to put that in perspective, that's about 36 km/h, which is the speed of an elite human sprinter. But this time it's performed by a full-sized bipedal machine. Bolt is 1.75 meters tall, weighs about 75 kilograms, and was built with a very clear philosophy: to imitate human biomechanics while pushing its own limits. According to the company, the robot uses newly designed joints, advanced damping systems, and an optimized power set to maintain continuous power, even at high speeds. In practice, this allows the robot to take shorter steps than a human runner, but with an absurdly faster cadence. That's less amplitude and much more frequency. It's like trading long strides for a quote-unquote shuffle. In a promotional demonstration, the company's founder ran side by side with Bolt. On a treadmill, the human seemed to be at full speed, while the robot looked like it was just warming up. Mirror Me claims that its goal was never just to create the fastest robot in the world. They talk about something much more ambitious: developing what they call super species robots, machines capable of reaching, matching, or even surpassing human athletic abilities through advanced perception, refined motor control, and structures specifically designed for performance. This focus on robotic athletics is not something isolated. China has been investing heavily in this area, with events dedicated to competitions between humanoids and race records being broken in recent years. That's right, my friends. And when technology stops being just a laboratory curiosity, the real competition becomes about who can produce millions, not just demonstrate that they can do it. Tesla entered precisely for this reason. Then, during the presentation of the financial results for the fourth quarter of 2025, Elon Musk announced something that just a few years ago seemed unthinkable. The company is going to end production of the Model S and Model X. Not because of failure, not because of a drop in sales, but to make room physically, financially, and industrially, for a single purpose: to produce humanoid robots on a scale of millions per year. According to Elon Musk, the Fremont factory in California will be partially converted to become a dedicated line for the third-generation Optimus. In practice, Tesla is trading luxury cars for artificial workers. Musk described the decision as an honorable conclusion for both models, making it clear that the company's priority is no longer to sell vehicles, but to manufacture workforce. And this shift comes with an aggressive investment plan. More than $20 billion by 2026, which are allocated to the construction of 6 new factories, including a unit dedicated exclusively to this purpose, robotics, as well as a massive expansion of artificial intelligence computing infrastructure. For Musk, Optimus is not a product. It's the foundation for a new economy. He says that Tesla's mission now is to create an incredible future of abundance, where robots take on almost all physical work, allowing something close to that, of what he calls high universal income. Universal basic income. Musk calls it high income. We hope it's good, right? But this future, according to him, starts slowly, very slowly. Musk described the initial production phase as agonizingly slow. The reason is simple. There isn't a supply chain ready for humanoid robots today, at least not here in the West, right? Every actuator, every motor, every sensor, every joint, every board, everything needs to be reinvented for a new type of machine. Tesla's internal goal is to reach a production cost of around $20,000 per unit. But Musk admitted that the first models would cost much more because the cost, in his words, will always be defined by the part, the system's most fragile, rarest, and least reliable part. Then came the phrase that ignited the industry. When asked about the competition, Musk said, "As far as we know, we don't see any significant competitors outside of China." In his view, Chinese companies are currently the only real threat because they dominate 2 critical factors: the ability to scale production quickly and the practical application of artificial intelligence in the physical world. This statement by Musk ignored major names in the North American scene, such as the company Boston Dynamics, for example, which is South Korean, but is located in the United States and was founded there. And it recently introduced the Electric Atlas, ready for production. Another one is Figure AI, which recently showcased its Helix 02 system controlling robots with full-body autonomy, as well as several others here in the West. To conclude, let's mention Onyx Technologies, which develops world models capable of allowing robots to imagine tasks before executing them. Despite all this, Musk seems convinced. For him, the battle won't be won by whoever has the best robot today, but by whoever manages to build factories capable of churning out robots on an industrial scale. And this is exactly where Elon Musk's plan comes in, the so-called terafabs, facilities where Tesla intends to integrate everything in a single location. Manufacturing of artificial intelligence chips, memory, electronic power packaging, and final assembly. According to Musk, a robot without an artificial intelligence chip is just an expensive mannequin, and relying on external suppliers for these chips would be an unacceptable geopolitical risk. And that's exactly why Tesla wants to control everything, from lithium to silicon, to the robot walking. If this plan works, Tesla will stop being just a car manufacturer or an energy company. It will become something new, a maker of artificial specimens, but right now. So while we're talking about artificial intelligences gaining bodies, they're also gaining so-called digital hands. And all of this is happening within our own systems. It's a fact that in recent years, artificial intelligence has been trapped inside chat windows. You would ask, it would answer, and everything apparently ended there. But that phase is coming to an end. A new kind of artificial intelligence has started to quietly spread across the internet. Not so quietly, actually, because there's a lot of buzz about an AI that not only talks, but acts. It reads your emails, organizes your files, executes terminal commands, controls devices in your home, and can reply to messages as if it were a friend of yours. That said, Peter Steinberger created the project, which was previously called CloudBot, and now it's named OpenCloud. In practice, it works like a personal operating system based on artificial intelligence. You can ask it to summarize reports, monitor servers, rename thousands of files, organize folders, send messages, track stock prices, and even trigger home automations. All of this without opening a specific app, just send a message. But that's exactly where the problem arises, because OpenCloud isn't just a chatbot, it's an agent, an autonomous agent. Unlike traditional AIs, which in quotes, sleep until they're called, agents like the so-called Mobot seem active, monitoring events, making decisions, and continuously taking actions. This is the beginning of the so-called era of agentic AI. And the moment an AI gains access to your files, your terminal, and your accounts, it stops being just software. It becomes a digital operator. From what I'm noticing, we're witnessing the birth of the first draft of something much bigger. Maybe something similar to the embryonic moment of Jarvis from Iron Man. But every Jarvis, before becoming a hero, needs to be tamed. And technology isn't the villain, in my opinion. And, by the way, it's not the salvation either, okay? It's actually an amplifier. And from now on, what will define the impact of AI on our society? It's not how powerful it is, but how well we learn to control it. If you like this episode, go ahead and leave your like and check your subscription, okay? If you haven't subscribed to Aria yet, take the opportunity and try out our artificial intelligence for 7 days. The link is in the description, pinned comment, and here. Thanks for staying with me. See you next time. Click one of the 2 suggestions on your screen. Thanks. Bye-bye. If you like to check, the sources are always in the description. All right, see you in the next one, my friend. I'll be waiting for you there. Click there.